Okay, so this was asked, this problem. So we have this paired data, and I'm going to show an example using Excel. I'm going to show a little bit different, but then I'm going to show why I use Excel. So here in this one actually wants confidence interval, but that's beside the point because these answers are going to be used for the other one. So what I do is I put the data in here, so you can see the first column matches my X's, the next one matches my Y's, and then this column, and whenever you click on a cell, if you look at the spreadsheets, it'll show if there's a formula. So this says A8 minus B8. Well, even if I double click on it, it shows what I'm doing is I'm getting the difference between my X and Y values. So each one of these, and you can kind of see 4 minus 6, 8 minus 5, each one of these I put a formula to give me those differences, okay? And then here I'm going to get the sum of those differences. Why did I get the sum of the differences? Because then if I want to find the mean difference, okay, so finding the mean difference, I either could have taken that sum and divided by the number of values, or in this case, I just used the average. So that gives me the mean difference. For my formula over here, I'm going to actually need the each difference minus the mean difference and then square it. So if you look at this, this takes each individual difference. Okay, so that's C8, and then it subtracts the mean. Now, when you see these dollar signs, the only reason those are on there is because I copy and paste this formula straight down. And when you do that, notice the first term is C8. Well, when I copy, it moves down, and I don't want this one to be moved, so it's going to just keep that formula. Or basically, again, I'm just taking each individual value and I'm subtracting it from the mean difference, and then I'm squaring it. That's that caret, they call it a caret. I don't know why they call it a caret, but this shift 6 and then 2. All right, so over here, I really didn't need this column after I was looking at this, but all I did here was sum these values, so it's the same as column D. So I just simply sum those. And this allows me to find the standard deviation, because first I can find the variance by taking this sum and dividing by the degrees of freedom, which is n minus 1. So once again, I could have just said equals this value divided by the degrees of freedom, so the number in the sample minus 1, and you see I get the same answer. Okay, so that was my reason for summing that. And then you take the square root, so you can see the square root of the variance gives me my standard deviation. All right, so over here to get my t statistic, notice it's a formula again, that I'm taking the mean difference, that's what that line means over it, for this sample, minus the mean difference of the population. Well, we're saying there's no difference, so I went ahead and put minus 0 so you could see it, and then divided by the standard deviation divided by the square root of the sample size. Okay, so I'm just referencing these cells, and again, you're going to see why here in a minute. The t critical you could look up in a t table in your book, you know, and so in other words, you have the normal table and you have a t-table as well. I was just lazy and said, well, let's just go ahead and use the formula because Excel has it. So this says, what is your probability? Okay, so the level of significance, mine was 0.05, and then degrees of freedom is n minus 1. And when you use this, it actually gives you the value in the table. All right. So now I'm going to show you why I push you guys to use Excel. And I know some of you, it's new, you're scared of it, but I'm hoping when you see this, you will say, oh, this is why she wants us to use Excel. So watch what I'm gonna do. Let me make sure I can see all these values. Is that all of them? Yeah. So once I set this spreadsheet up once, and let's say that I'm going to be taking a quiz. And it would be nice if I saw this, or even on the test, this same type problem again. Well, I don't want to build this spreadsheet every time, and this is why you see me reference cells, okay, instead of just typing 5 minus 11. Watch what happens. I'm going to change my x values and my y values. So my x values are 10. See the numbers changing? 4, 13, 5, 20, 7, 0. Now I'm going to change my y values, 11, 8, 6, 13, 8, 15, 10, 5. And now notice I'm done. There's my mean difference. There's my standard deviation. There's my t-value. And there's my t-critical. This is why you want to use Excel, because now I have a spreadsheet set up. And in fact, this one's actually set up to also do confidence intervals. So the confidence interval is where you take the mean difference minus the error and the mean difference plus the error. But now I have a spreadsheet that I can use for test questions anytime I get a mean difference on the test. And this is the beauty of using Excel versus using your calculator.